Forests are under pressure for sequestrating carbon, for climate mitigation, providing wood-based products, hosting biodiversity, etc. At the same time, they face a number of climate-driven stresses, such as drought, fire, snow, and wind. Windstorms are one of the most important forest disturbances in Europe, responsible for more than half of the timber volume loss in the past decades. At the local scale, the storms can have devastating consequences for forest owners and the forest industry, but also in terms of social and ecological impacts. As one agent of extreme forest damage, mapping the vulnerability of our forests to storms is crucial for the forestry sector. And this is what we're doing in Norway to support the forest stakeholders in identifying vulnerable areas and adapt management practices to build up resilience. However, assessing the storm damage risk in forests is complex because it depends on the characteristics of the trees, the soil, and the landscape. Therefore, we need to combine national data and models into simple and useful risk metrics. First, we need a map of the forest attributes, such as the tree species, the tree heights, at a high spatial resolution. By combining remote sensing data, topography models, and the National Forest Inventory data, we have at our disposal in Norway a detailed national map with a spatial resolution of 16 meters. Second, we need to translate these forest characteristics into a simple risk metric. The forest scales model developed by Forest Research in the UK is a process-based model that does just that. It calculates the critical wind speed, so the wind speed at which stem breakage or tree uprooting occurs, for a single stand or a single tree. By applying forest scales to the Norwegian forest map, we obtain a current map of the vulnerability of forest to storm damage for the 3 billion forest pixels in Norway. We can then identify the vulnerable areas more likely to suffer damage in the next storm and adapt management planning accordingly. But we can do even more and predict the future vulnerability by using our high forest resolution map and predicting for the next 20 or 50 years using forest growth and dynamics models and forest scales under different climate and management scenarios to paint a picture of the vulnerability for the future. And then we can identify management strategies that are more likely to decrease the risk for our future forest. So in conclusion, this work on current and future vulnerability can help adapt management strategies to build up resiliency in the forest ecosystems and the forest-based economy. Thank you.